Welcome to Tech Diet. Let's dive into our today's problem, single number part 2. Given an integer array nums where every element appears 3 times except for the one which appears exactly once. So we need to find this single element. Okay, that said you need to implement a solution with the linear time complexity and with no extra space. So okay, we are given this array. From this 3 is the only element, so we return 3, and from here 99 is the single element, the rest are 3 times repeated. So okay, so if someone has solved this single number problem 1, we'll know there will be a single number which is repeated once and this other was repeated twice. So in that case we'll have done some bit operation. We have done the XOR operation because we know XOR of a and a is 0. So and XOR of 0 and number is number, so we'll end up into the single number. So similarly here also it should be some bit manipulation if it has to be a linear uh, time complexity. So let's just look over our data. So how I can represent 2, the other 2. So here how I can represent 3, the other 3, the other 2. So if we notice, we know, okay, the number of bits that are at 0th position. So we have here 1 bit. Number of bits are at 0th position is 4. Number of bits are at the second position is 0. So here we have 4 bits. So since every number is repeated thrice, that's a mandatory. So if 2 appears once, so it has to appear 3 times. Let's just write it there. So it appears 3 times. So if numbers appear 3 times, we can ignore it, right? So I can know if at position bit position I, if that position is 1 and that 1 is seen 3 times, we know okay that must be part of that 3 groups which are repeated thrice. So we can ignore that, and only if it's once it's seen, then only we can add back to our result, right? So if we look at the range, it's always lie in the 2 raised to power 31. So that means there will be 0 to 31 bits that we can have in a number. So so that will be our starting point. So we'll start with the 0 till 31. So let's do the upper index 32. So after that, what we need to say, okay, we need to iterate through the numbers. Let's iterate through them, and after that I need to check whether the corresponding bit is, for once we traverse through all of these lists, whether the corresponding bit is 1 or 0. So to find that, what we can say, if n, we need to do the right shift right for that position, right shift it that many times, and 1, is this equal to 1, is this a bit set? So if this bit is set, then we need to say we can increment the count, right? So let's just declare that count. So this is like for the 0th bit, how many times this bit has been set. So far we'll see, okay, it's set only one time. Once we have done that, after all the iteration, is that a multiple of 3? uh, but we don't want them. So if it's not a multiple of 3, that means it was just seen once. So we can add it to our result, right? So we can say result plus that bit. So we need to form that. Maybe we can use or on the corresponding bit, and that has to be right shifted that many times. So we need the 1 at position I, we need to left shift it because here we are ignoring the right bits, here we are making them. So we'll say if it is there, then we can just at the end of my, once all the bits are considered 0 to 31, we can say okay, that will be my answer. Let's test this out. So it says illegal start of expression. So what we have done here is, if this should be like this. Okay, we need to return the result. Okay, looks like this is working. Let's just test it with some non-divisible number 3. And okay, let's just try to hit submit. Yeah, this works. So yeah, that was the intuition behind. We'll release the corresponding bits. We'll check whether the particular bit is seen as a multiple of 3. If it has been, that means it must be part of thrice group. Otherwise, if it not, we can add back to our result. So yeah, thank you.